Hello. Well, today I have a new question for you. I was going through 450 DSA.com and I chose array. Yeah, so this is one of the questions from the set of questions, which is move all negative elements to the end. And the question is very simple. There is an array which has both positive and negative integers. We have to move all the positive numbers to the left side and the negative numbers to the right side, like shown in the output. And what we need to take care of is we should not change the arrangement of numbers. So all the positive number should come in uh, just the way they are put, like it's 1 and then 3 and then 2. It cannot be 1, 2 and then 3. Right? Okay. So that's yeah, we need to take care of. And when I went to the editorial here, I saw two approaches. One was to use uh, two arrays, actually one array here, where they will first store the positive integers, and in another array they will store negative integers, and yeah, then they will combine it. Okay. Yeah, yeah. First we store all positive integers, and then we store all the negative integer in temp, and then we copy, yeah, temporary array to the original array. And there was another method which suggests to use stack. Okay, yeah, here. So this method suggests to use a stack, to use two stacks, positive and negative, and it's also easy. Just you know, whatever positive number you find, you put it, and in the negative stack, you just put all the negative numbers, and then put it back to the original array one by one. I like starting from the positive and then negative. However, I discovered, like I was pondering, okay, since both of these use extra memory, uh, is there a way to not use extra, array, uh, stack or anything? Okay, we should just be using the memory given to us, the array. Maybe slightly more, but it's okay. So this is what I came up with, to use pointers here. Yeah. So we'll go through loop, right? And we'll stop when we find a negative integer. Okay. So when we find a negative integer, stop. Okay. Right. And then we will run another loop. Okay. Another pointer. Okay. Till we find a positive one. Okay. Once. So yeah. And when we find a positive one, right? So okay. I'll iterate one more time. So we will start with a pointer, and we'll stop when we find a negative integer. Then we start another pointer from it, and we'll stop when we find a positive integer. Once we find a positive integer, we will keep swapping, okay, till it comes to till the positive integer comes to the right side of the negative integer, right? So in this case, uh, we'll swap these two, okay, which will so after swapping, it will look something like 1 and then 3 and then negative 1 and then this. Okay. So now we'll move forward this pointer here. Uh, yeah, one more. So we again found the negative. Of course, we will find the negative number here. Right. And then we will start another pointer that will stop at 2. Right. So we'll then swap these two. right? So then they will be like 2 here, -1 here, -7 here. Okay, now write the rest of it as well. Hmm. Now our pointer, and now we'll again increase our pointer, and we have negative integer here. Now we will move the second pointer. So we are here now. Now we'll move the second pointer until we find the positive integer. Okay, so we'll see come to the next one in the array. It's -7, so we'll move further one step. It's -5, and they will, and then we'll move one more step. 11. Now this is the positive integer. Now we'll keep swapping until we move to the right side of 11, right? Okay, so we'll first swap 5 and 11, right? So then it will be like 2 -1 -7, 11 -5, 6. Then I'll just uh, uh, now we'll swap -11 and 7, yeah, sorry, -7 and 11. Then it will be uh, and now finally we'll swap to -1 -7 -5, 6. Okay, and yeah, so we have finally moved 11 to the right side of -11. Okay, and our pointer was here. Okay, so we'll move one more step now, and we will keep moving our second pointer until we find the positive one, which is at 6. And then we'll again keep swapping 6 until we move to the right side of -1. So ultimately it will come as 5. And before this we had 1 and 3, right? 3. So this is our final result, which should match with our 1, 3, 2, 11, 6 minus 1 -7 -5. 1, 3, 2, 11, 6 minus 1 -7 -5. And so this is how we are going to approach to the problem. And I've already written down my solution here, and it's in C sharp. Okay, this is just the main function, and it will call our sort array. Okay, so this is what I'm doing here, looping starting with 0, and I'll keep moving until I find a negative integer. Once I find the negative integer, right, then I'll start another pointer. Okay, and I will move it, right, and I have put a condition that should be less, uh, because at the end we should not cross the array, otherwise it will throw array index out of bound exception, right? Okay, so for that I have put a condition here. So and then we'll keep moving our second pointer until we find a positive integer, right? So now when we find a positive integer, then yeah, again I put this so it does not throw us any error. We will keep swapping this until we move to the right side of the array. Okay, This is a normal swap function where I pass the reference. And if I run this with our given array, then you see 1, 3, 2, 11, 6, -1, -7, -5. It matches our solution output here 1, 3, 2, 11, 6. Right? Yes. Now I have a question for you guys. Since I have told you the solution, you guys tell me what should be uh, the time complexity for this solution. Like, is it better, worse? What what is it compared to the solution mentioned in the editorial here? That's it. Yeah, you guys can comment it down, and I'll reply to you. Thank you. Bye bye. Until next time.